thank you for having me here this evening. You know, one of the best parts of being a journalist is the fact that I can investigate a wide range of topics, and tonight I get to delve into the world of biology with the leading minds in the field of that science. Our first guest's interest in chemistry began at an early age, when he was in elementary school and liked to mix the contents of his household medicine cabinet. I'm sure Mom and Dad loved that. He received his BS degree in chemistry from Morgan State College in 1974 and subsequently pursued his PhD with a major in biochemistry and a minor in neurobiology from Cornell University. He received a coveted postdoctoral staff fellowship at the National Institute of Mental Health before being appointed assistant professor of biology at Brown University in 1983, and later associate professor in 1989. At Brown, he serves as the Upjohn Professor of Pharmacology and chair of the department. His current work includes a complex field that combines chemistry, pharmacology, neuroscience, and cancer biology. Ladies and gentlemen, Dr. Wayne Bowen.
Thank you very much for that introduction. It's really a pleasure and an honor to be here tonight to talk to you about some of the work we've been doing on sigma receptors in cancer. However, since those two kids in the video have already cured cancer, I probably don't have to say too much. How many of you out there have known someone or who has had cancer or whose lives has been impacted by cancer? And lots of hands go up. So cancer, as you know, is a very prevalent and widely spread disease. And what we're trying to do is find novel ways to treat cancer. So what is cancer? Cancer is the abnormal and uncontrolled growth of cells in the body. And most cells have a built-in biochemical program that will initiate sort of cellular suicide after the cell reaches a certain age or after it's gone through a certain number of divisions. This process is called apoptosis, or programmed cell death. And cancer cells have learned how to turn this process off. They've been able to disable this process so that they continue to divide and divide. And cell growth can also be stimulated by our body's own growth hormones. So, for example, some breast cancers are stimulated by estrogen, the female sex hormone. Prostate cancer can be stimulated by some derivatives of testosterone. So cancer cells have sort of hijacked our own cellular systems for cell survival. And these abnormal cells can spread from the original tumor site to other sites by a process called metastasis. And there are various ways to treat cancer, but most of the problems with the current drugs that are used to treat cancer, as you know, there are lots of side effects: hair loss, vomiting, all sorts of very bad side effects. And this is because these drugs tend to be not so specific. They kill cancer cells in addition to our normal cells, and that produces all of the side effects. So one thrust today is to try and find more specific ways to target cancer cells. And so our work, the impact that I think that our work will have for medicine is to find a novel target. And this particular way of treating cancer is called targeted therapies, where you find a molecule in the cell that you can target with drugs that will turn that cell death process back on. And the way we are trying to do that is through activating sigma receptors. Now, what are receptors? Receptors are proteins in the cell or on the cell or in the cell that specifically recognize chemical substances like drugs or hormones. And when the drug or hormone binds to the receptor, it turns on a series of biochemical steps that I say some biochemistry happens here, which ultimately results in a response in the cell. And what we're trying to do is target the sigma receptors to produce a response, and in this case it would be turning back on that process of cell death so that we can kill the cells. The evidence that sigma receptors are involved in cancer are manyfold. One is that tumor cells, both solid tumors and what we call cell lines, and I'll say more about cell lines later, express high levels of these sigma-2 receptors. And in fact, the levels of these receptors go up even higher when the cells are in a state of rapid proliferation. So aggressive cancer types that divide rapidly and develop tumors very readily express even higher levels of these receptors.